Hello again. We finally have stuff in our house, so I've got some nice stuff behind me today instead of just my blank wall. So today we're doing section 9.4 on glide reflections, which are kind of a combo of everything that we did last week. So your learning target is to be able to classify and find glide reflections. So if you're setting up notes, take a minute to do that. Okay, so I've got a quick do now for you just to kind of get a little bit of review in since it's been the weekend probably since you did any math work. So you've got three different steps. So what we're doing today is we're going to start combining together the things we learned last week. So we're going to kind of hint at that in our do now here, and then we'll obviously make it a little bit more formal in our notes. So for your do now, your first step is to graph triangle CAT. And then you're going to graph the image of t negative 2, 2. So remember that means we're going to translate triangle CAT by negative 2, 2. So backwards 2 and down 2. And then on the same graph, so you're going to do this all together. So I have my graph over here to kind of show you in just a minute. We're going to graph the image of R x equals 1 triangle C prime A prime T prime. So what that actually means is you're going to reflect the triangle that you drew in step 2. So you're actually going to take the triangle from step 2 and reflect it over x equals 1. Okay, so take a minute and pause if you need to, and then I'll show you kind of what my do now would look like. So my step 1 for graphing triangle CAT looks like this. So if you haven't already paused, I would really encourage you to actually pause and take a minute and try it yourself so that you're not just kind of hearing me do it. If you actually do it yourself, you're gonna get the review in much more efficiently for your brain. So number 2, it says graph the image of the translation of triangle CAT negative 2, comma 2. So that means that we're moving it to the left 2, right? Negative 2 on the x-axis. So we're moving it from point C, for example, we're going to move it C over, and then we're going to move it 2 up. So backwards 2, up 2 for C, and then I'm going to go backwards 2, up 2 for A, and then I'm going to go backwards 2, up 2 for T. So my new C prime, A prime, T prime triangle kind of ends up in this upper left quadrant of the graph. And notice I've labeled my points, so please do that. And then it says on the same graph, we're going to reflect that triangle from step 2. So my orangey pink triangle that I have right here, I need to sketch in my line x equals 1. So remember from last week, since this is my x-axis right here, I'm going to find 1 on the x-axis, which is right there. And then the line x equals 1 goes straight through the x-axis. So there's my line. So that's x equals 1, and then I just want to take that orangey pink triangle and reflect it over the green line, right? So that means, remember reflections from last week, if A is 1 unit away from the line, or sorry, A prime, I guess in this case, then A double prime will be 1 unit away in the opposite direction. Same thing, C prime here is 1, 2, 3, 4 away, and then 1, 2, 3, 4, whoa, I lost count, 1, 2, 3, 4 in the opposite direction. And then T prime is 2 away, so T prime will be, or T double prime, excuse me, will be 2 away in the opposite direction. So you see we just kind of took it and flipped it over. Make sure that you have all your points labeled. Remember when we do double, kind of like anything where we're doing it twice, we're gonna use the double prime or triple prime notation like we used in the rotations lesson. So there's your do now. If you have any questions, send me an email as always, but we're gonna move on here. So little review from last week again. So remember we talked about a rigid motion or an isometry is a transformation that preserves the size, but not the location of a point or a shape, right? So it's staying exactly the same, but it's just moving around to different places. So the ones we talked about last week are a translation where it just shifts from one place to another, a rotation where it is turning or flipping, and then a reflection where it flips over a line. Today, what we're going to talk about is this thing called a glide reflection. And you can't actually see, but right kind of underneath where this gray R, there's actually another R that is flipped over. So imagine you can see another R kind of right here where my pointer is. So glide reflections, I'll show you the definition on the next slide, but you can see that it actually kind of slides, and then if you could see it, it flips over that line. So here's our formal definition of a glide reflection. It's the composition or kind of combining a translation and a reflection across a line that's parallel to the translation. So the kind of diagram to explain this, if I start at this black paw right here, and then I translate it up to where this new gray paw is, and then after I translate it, then I reflect it over this line over to where the blue paw is, right? So I've combined this first movement, this first transformation of a translation, and then also combined it with this reflection, okay? So it's pretty self-explanatory, I think, in the name, right? It's a glide reflection. That's it, okay? So before I actually show you kind of how it works, I'm going to talk to you a little bit about notation on the next slide. Okay, so we have some special notation that we use for these things called compositions. And composition just means that rather than just doing one thing, we're doing two or more things. We're going to stick with two. But let me remind you from algebra, and now we don't talk about this in Algebra 1 at Kentridge, so maybe it's an Algebra 3-4 topic, but I remember learning about it in Algebra 1 in school, so who knows? But I'm just going to give you a little sort of quick intro. In algebra, we do talk about functions in Algebra 1 at Kentridge. Do you remember functions? So we would say, for this one right here, we would read that as f of x equals x squared, right? So that means that basically this function is equal to x squared, and I could plug in 2 for x and plug in 2 over here. Well, 2 squared is 4, right? So when x is 2, the function's equal to 4. Maybe I plug in 3, right? When x is 3, the function's equal to 9. So we're basically just taking something, plugging it in. Like I talk to my students about a function machine. You put in an input, you get in an output. So here's another function, so g of x. So if I plug in x, let's say I plug in 3 again. If I plug in 3, my function becomes 3 plus 1 or 4, right? So just a quick review from algebra of functions. So composite functions are, this is what I think is maybe an Algebra 3-4 topic, but I just want to sort of give you guys an intro to it because it is really interesting. When we do composite functions, this looks like fog. I always read this as fog as a student, but really this is f of g of x. And what that actually means is that we're taking our f function and we're like plugging in g of x into where x should be, okay? So what that really means is, well, g of x is equal to x plus 1. So really I'm taking my function and I'm plugging in x plus 1, right? Well, what that really means is since my f of x function is equal to x squared, I'm really taking x plus 1 and plugging it in where that x should be in the x squared. And then what that really means is then we go through, right, and we multiply it out, x plus 1 times x plus 1, multiply. So your final answer for that one would be x squared plus 2x plus 1. The point here is not that you know how to do this type of math. The point is that this notation right here with the little, that tiny little circle, that's what we use for these things called compositions, which is when we combine two different functions together. Okay, I'll post some Khan Academy videos for those of you who are interested because it is kind of a fun algebra topic. But here we go on transformations, how this actually applies. So in example 1, it asks us to find the image of a glide reflection. So we know that in glide reflections, we have to both reflect something and we have to translate something. So just like our functions, we're doing two things to our triangle, right? We're reflecting and we're translating. So here's the interesting thing is from our notation, we actually had to sort of deal on our last slide with the g of x first, right? We plugged it into the formula and we kind of took care of the g of x. And then after that, we looked at the kind of outside f of x function. So the weird thing that trips some geometry students up about glide reflections is that in the notation, we actually have to put the reflection first and the translation second. But what it actually tells us to do is to translate first and then reflect second. Okay, so if you ever are wondering, what is this rule telling me to do? Remember that we're going to be sticking with glide reflections. We glide first, we reflect second. Our rule, just because of the way that we notate things in algebra and geometry, we kind of flip them when we write our rules. So what this is actually telling us, if we're trying to reflect and translate triangle TEX, here's the coordinates of TEX. So I'm going to go ahead and graph those. Boom. Take a minute to do that and pause it if you need to. So there's my triangle, right? So the first thing I want to do to it is I want to take it and translate it. And this tells me I'm going 0 in the x direction and -5 in the y direction. So I'm going down 5 in the y direction. So there's my new TEX triangle that's been translated down. So remember, our definition of a glide reflection tells me that it has to be parallel to the direction that I translated. So since I've translated kind of in this up and down direction, notice that it says that I need to reflect over x equals 0. Well, x equals 0, if this is my x-axis, 0 is right here. That line actually is the y-axis, so it's just a different way to write it. So there's my line of reflection, and you'll notice that it is parallel to this line that I have here, right? So when I do my reflection, I want to go down and do my translation, and then from this translation, then I do my reflection, right? So here's like step 1, translate, step 2, reflect, okay? Notice that I did not use double prime notation here. I just used single prime because technically this is my starting point, right, up here, and then this is my ending point, okay? This is just an in-between step, and really what we're looking for is here's my image or my pre-image and here's my image, okay? I do want to see on your homework, or what I would recommend to you, is to actually go ahead and graph that second or that kind of in-between triangle, because it does help you see and it helps you find errors. But if I asked you just to do this glide reflection, you'd go from the pre-image, which is here, to the image, which is here. And that orangey pink triangle is just sort of there as a second step. But that counts as showing your work, which is important. Okay, so example 2 asks us to describe the isometry that maps shape A to shape B. So remember, we have to describe it as a glide reflection. So we're kind of looking for both of those things. So if I want to think about, okay, first of all, how is my shape gliding so that it's getting to a point where I can reflect it? Well, it looks like I could take this shape A and just kind of slide it over this way, right? And so if I slide it over that way, that's my glide. Okay, and then it looks like I could just take this light blue shape and reflect it there over the x-axis, and I would end up at shape B. So the way I would describe my glide is that if I count out how many kind of bounces or how many units I moved over 6 units in the x-axis and 0 in the y-axis. Remember, this is a really common error. A lot of students want to pick a point, right? So pick this corner up here and go 1, 2, 3, 4, 5. And they stop at this corner, but you have to match up the original point to the new point over here, which is all the way on the right. So we're actually going from this right corner, 1, 2, 3, 4, 5, 6. So just kind of keep an eye out for that. And then when we do our reflection, we are reflecting over the x-axis right there. So there's my reflection. And I put that you could also say that it's y equals 0, right? Because technically, if we're looking at the y-axis, y equals 0. So when I combine those together, remember I have to write the reflection first and the translation second within my rule. So here's my rule, and I'm so sorry that got cut off, but we're going to combine together the x-axis reflect over the x-axis and then translate 6 to the right, 0 on the y-axis. And then I actually did have under there that it said shape A. Okay, so reflection first in the rule, translation second in the rule. Example 3, when we're identifying it tells us to identify each isometry, and then we want to write a rule to describe it. So we're going to go a little more practice here with kind of that glide, reflection, glide, weird writing that we have to do. So the first one it wants to us to describe is triangle ABC going to triangle MNP. So if I look over here, I see triangle ABC is right over here. I'm just going to give that sort of a highlight, and I'm going to erase that when I do my second example here. But so there's triangle ABC, and I'm trying to get it to triangle MNP, which is way over here. Okay, so I'm going to have to do some kind of a shift, right? And obviously, if I'm going from this triangle here, I'm going to have to shift it way over to the right somehow. I don't know if you can see that arrow I just drew. So I've got to shift it way over to the right somehow. So that's going to be my first step, is that shift. And I'm sorry because I'm drawing with my finger here, but when we shift it, it's going to end up something like that red triangle I just drew. But if I shift it over that way, it does look like we can nicely reflect it over the x-axis again, which is good, right? So we have a reflection, and I have to count this every year, but I'm pretty certain that it's 13 points. So if I go from C, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 over to the C prime point. So I'm going to be translating it 13 to the right and 0 on the y-axis. And then I'm going to be reflecting it over the x-axis. So take a look here. I have my translate 13 comma 0, and then I have my reflect over the x-axis, and I put, just for good measure here, I have my triangle ABC. Technically, we could probably do without the ABC, but it just, especially because we have so many shapes here, it just makes it really clear that I'm doing all these things to triangle ABC. And we could even throw on the end there equals triangle MNP, right? That's kind of what we're trying to get to at the end of our glider reflection here. So now we are going to be working on triangle MNP and taking that to triangle JLM. So I'm going to erase what I have here and leave MNP highlighted. So we're trying to get to JLM, which is right here. Okay. So it looks again, well, there's actually a few different things we could do, right? So I would actually encourage you to maybe pause it here and see if you can figure it out yourself. So pause if you need to. Students a lot of the time will want to kind of start by thinking, could I shift it down and then reflect it? But if you look, if you shift it down, that kind of shifts your triangle to something like that, which is not going to be very easy or clear to reflect. So I'm going to get rid of that. So the other option is to try to shift it horizontally. So what if I take my triangle and I try to shift it this way? That gives me some kind of a shape that looks like that, which that shape, that red shape I just drew, does look like it could be easily reflected over the x-axis, okay? So it looks like I took my point that's here, point N, I'm going to start with that, and it looks like I went backwards 2 in the x direction, so that would be like a -2 shift. So I translated it -2, 0, okay, and then again I'm reflecting over the x-axis, and I'm starting with triangle MNP and getting it to triangle JLM. Okay. So for your assignment, you're doing page 574, and as always, please use graph paper and a straight edge. And then I would encourage you to color or highlight your images, which, remember, image means your ending point. So you have your pre-image that you're starting with, just do that in pencil, and then your image or your ending point, give those a highlight. And I have some students too in past years who like to have kind of a color code for their second step, because you're going to have to do the translation and then the reflection. So some students will color the translation one color, and then their final image of the reflection they'll do in another color. So that is up to you. I'm only going to be glancing at your homework assignment. It's more for your learning and your knowledge. If it will enrich you, go ahead and do it. Have a great day.